Have you ever seen an amazing project online and thought, I want to do that too? It might look very simple at first and easy on paper, but in reality, it can be very tedious and difficult to follow along without proper tools, knowledge, or techniques. In this video, we'll address all the issues and concerns while building a hardware project. In addition to that, we'll also see how to successfully finish an open source hardware project. Now, choosing a good open source project is very critical because the project's difficulty will vary depending on your skill level. If you are very skilled and have very good knowledge about the project, even if the project isn't interesting, you would end up completing it in a day or two. Similarly, if you are very passionate about the project, you would end up learning the skills eventually that you need to complete the project. But if you have neither, there is a high probability that you'll drop the project halfway through. So make sure to choose the project wisely based on your passion and skill level. If you're not sure where to find the projects that you like, these are my recommended sites. In this video, we'll be making this project, Mitayi, a Raspberry Pi Pico clone. I always recommend that you read the documentation created by the creators before diving into any project, because this documentation may contain project related tips and tricks that can potentially make assembling process much easier. Luckily for this particular project, we had a chance to talk with Vishnu, and he was able to explain everything in detail about the project, including the circuit, PCB layout, and also how he is sourcing his components. Apart from this, we also went through the dedicated document written on circuit state about assembling Mitayi. And if you're interested, you can also read the review we have written on Mitayi at PCBcupid. Before starting any project, make sure you have all the important tools. Again, this might vary depending on your project, so make sure to go through the documentation. But to make things simpler, we'll give links to all the tools that you need to get started with Mitayi and other several hardware projects, so make sure to check the description. Along with these basic tools, in this video, we'll also be using a microscope which was sent to us by LinkMicro. The microscope is optional, but in our case, it totally increased the efficiency of soldering and video recording. I'll put a link in the description where we discuss more detail about this microscope and its features. After selecting the project and reading through the documentation, find out all the components required for the project. In many cases, the creator will usually put a file called Bill of Material. This will contain all the materials required for the project. We can use this file to source all the components, and if you are lucky enough, the creator might also share info about the sites and locations where we can source the exact components. In our case, we did not have to worry about any of the components because Vishnu from Circuit State sent us the whole project as a kit perfectly packed. This particular project might be slightly difficult in terms of soldering as it uses a QFN package and a 0402 package for the passive components. So keep in mind, in any hardware project, make sure to go through the BOM and see if you are comfortable with using the components and also the materials mentioned before starting the project. From here on, follow the project instructions and documentation. First, inspect it if you had any damage on the PCB. According to the documentation, most of the soldering was done using a 0.8D tip. Since I had a rework station, I prefer using that to solder the SMD components. So I started with the largest SMD component like the RP2040. This way it would be way easier to solder using a hot air gun at a good temperature and a high flow rate without blowing away the smaller components. Once that's installed, I moved to the secondary components like the diodes, switches and the flash memory while reducing the flow rate a bit. This way, the secondary components would solder to their pads without flying away. Finally, to finish the assembly, I placed the capacitors, resistors and soldered them at the least flow rate to keep the components in place during the soldering process. After soldering, I cleaned the PCB with an IP solution and inspected for any shorts caused by the solder. This looks really good, but let's see if it functions. Well, that's not good, because I need to hear this sound once I plug this into the PC. But it seems like nothing is happening. There are quite some times you'll end up with roadblocks and problem like this because it's very rare that you get something right at the first try. So just don't give up until you figure it out. I think the open source community is very welcoming. So don't mind dropping questions on electronic forums, just like PCB Cupid. Or just contact the creator of the project, just like I did. But still, we weren't able to narrow down the problem. Finally, after a few hours of struggle, I found out that RP2040 isn't working. It could be because of many reasons. Either it was the manufacturer's defect, could have been the ESD, or maybe overheating. But unfortunately, I couldn't narrow down the mistake. Anyway, after replacing the RP2040, I see this was the result. Finally, I have a working version of Mitayi. So watch out for upcoming videos where we'll see if I can replace my future Pico projects with Mitayi. Just for sake of this video, I kept the number of problems to 1, but in reality it can be multiple. So don't freak out though. Eventually you will learn how to solve the problems one after the other. I am really not sure how motivating the whole video was, but I hope it gives you a gist of what is involved in an open source hardware project. Here I'm just sharing my personal process, and this might vary depending on person to person. So to find out your right workflow, keep working on various open source projects or start building your own projects. If you have already been working on an open source project for quite some time, please let me know what's your process. Also, any special tips and tricks that you'd love to share and make the hardware building process a lot easier. Anyway, now don't forget to like and subscribe to the video before you leave. If you have any questions or doubt, you can always join the PCB Cupid community to discuss a wide range of topics. Until then, keep learning and keep creating.